Hi, my name is Chris Reese, and I appreciate your interest in this video. I made it to announce a tool I just finished that I call Korbie. The name is short for Kerr Orbital Explorer. It enables you to explore the set of possible closed orbits around a spinning black hole. The program is free and open source to use as you wish. This program has its genesis in an online tool written by Dr. Niels Warburton, Royal Society Research Fellow at the University of Dublin. Dr. Warburton, whose name I hope I'm not mangling too badly, created what he terms a Kerr orbital sketchpad, which works within a web browser. By playing with a few parameters, the user can interactively explore the set of possible closed orbital paths a test particle can take around a spinning black hole. More technically, the set of geodesics in Kerr spacetime. Such orbits have a surprisingly complex and often beautiful structure. I used the Kerr sketchpad often when I was learning about the subject as an aid to visualization and a sanity check against calculations. Useful though the tool is, the web browser imposes some severe performance handicaps. An orbit takes about a second to plot. I began to wonder, how fast could this be made to run as a native app instead of an online tool? Could I make it 1,000 times faster? If so, could this result in a qualitatively improved visualization? What I really wanted was this: to grab any one parameter, say angular momentum of the black hole, and slide it from one value to another. I'd like to see the orbital path morphing from one shape to another in real time. So I rewrote the tool using Python for graphics and C for computation. I took some care to write fast C code, and was happy to discover it was fast enough to do what I wanted. In the spirit of speed, without further delay, let's take a look at the result. So here we have the orbital path, fixed in white, for the four parameters: A for black hole angular momentum, P for initial orbital distance from center, E for orbital eccentricity, and theta for initial angle of declination. In red, we can see an animation of a test particle as it works its way around the white orbital path. With the mouse, you can rotate and zoom. The projection on the floor and left wall can keep you from getting disoriented or confused as to whether the particle is heading toward you or away. You may notice there's no plot button anywhere. The essential feature of this program is that all changes are made live. The visualization updates in real time as you change a value. Let's see this in action. We'll click E for eccentricity. We could just enter a numeric value here, but it's much more fun to just click and hold an arrow button, or keyboard cursor. We can now see the orbit change shape as eccentricity increases gradually. If we want to go faster, to the right of each parameter is the delta for each step. I'll go up by a factor of 10 so we can move faster. One value that I found is good to play with isn't a parameter at all, but rather the number of orbital revolutions that we spin through for the plot. Increasing this value sometimes produces a tangled mess of orbits, but often reveals a good deal of structure and symmetry instead. So let's go back to eccentricity, turn the delta back down, and keep increasing. There we go. This one is kind of pretty. And that's all I really have to say about what the software does and how to use it. I encourage you to give it a try. I find it's pretty fun to just play with these parameters and watch what shapes emerge. The software is free and open source. Binaries are available for Ubuntu-based machines. I think they also work on some other flavors of Linux, but I'm not sure yet. If you have another Linux distro like CentOS or Arch, please feel free to try it out and let me know how it works. A version for Windows should be available in a day or two. I haven't got a Mac to test on, but please let me know if you need this ported, and I'll try to figure out something. Of course, you're also welcome to grab the source code and build it yourself. The only system requirement is OpenGL, which most laptops and desktops support these days.